Hi everyone! In this video, I will show you how to convert hexadecimal number to binary number. Let's have our first example, 95 hex. You always have to remember that each hexadecimal digit is equivalent to 4 bits. So we will convert each hexadecimal digit into its 4 bits equivalent. So we will deal with it per digit. Okay, so here we have 5 and here we have 9. Remember in our previous video, we use binary place values 8421. So we will use it here again. So we have 8421 binary place values for 5 and another 8421 here, binary place values for 9. The question is, what 4 bits is equivalent to 5. So from these place values, we have to choose which numbers will give us a sum of 5. Here we have 4 and 1 because if we add 4 and 1, it will give us 5. The binary bit for this position is 1 and for this position it's 1. And then we will have 0 for 2 and 0 for 8. So it means that this is the equivalent binary number of hexadigit 5. And for 9, we'll have 8 and 1 because if we add 8 and 1, we will have 9. So we will make this position a binary 1 and a binary 1. Then here we'll have zeros. The binary equivalent of 95 is 1001, 0101. We are just putting these two together, okay? So this is the equivalent binary of hexadecimal number 95. Okay, let's have another example. Let's have 3B8. So here we have 3 hexadecimal digits. Again, we will use the 8421 binary place values for each hexadecimal digit. So this is for 8, another one for B. So this is for B. And then for 3, we have another 8421 place values here. So for us to have 8, we need to make this position a binary 1, and then these 3 positions will be zeros. This is the equivalent binary for 8. And for B, remember, A is 10, B is 11 in denary. Okay. So B is 11. So what place values here can we add to have a sum of 11? So we'll have 8, 2, and 1 because 8 plus 2 plus 1 is 11, and then this position will be 0. This 1011 is equivalent to B. And then for digit 3, we have 2 and 1. 8 and 4 positions will be zeros, and then we'll have 1, 1 for this position and for this position. We will just put this together and we'll have 0, 0, 1, 1, 1, 0, 1, 1, 1, 0, 0, 0. And there you go. We have the binary equivalent of 3B8. So this is the binary equivalent of 3B8. Actually, we can rewrite this number without these two leading zeros. You can have 1, 1, 1, 0, 1, 1, 1, 0, 0, 0. So these two are the same. So this is the binary equivalent of 3B8. So that's it. If you haven't watched the previous videos about conversion between denary and hexadecimal and vice versa, and also binary to denary and denary to binary, you can just watch the videos in this playlist. Bye.